Okay, so this is a typical stoichiometry problem. Stoichiometry problems 99.9% of the time involve a chemical reaction. Okay, that means you're going to have a chemical equation to balance. So step one of any stoichiometry problem is balance the chemical equation. Okay, so we have a chemical equation here. We have methane, CH4. It's going to burn in an oxygen environment, giving us water and carbon dioxide. Okay, and I said 15 grams of methane burns and oxygen produce water, carbon dioxide. How much water is produced? Okay, so we have a couple things going here. One, we have an equation to balance. Boom. Now, if we were in 1A, I would give you the paragraph and you would come up with the equation. Okay, we're in Chem A, not 1A. So I'm going to give you the equation. Okay. All right, so is this balanced the way it's written? Sometimes it is, sometimes it's not. In this case, you're right. It's not balanced. So I'm going to quickly balance it. Now, one thing you're going to have to do, if you can't balance the equation, you're going to bomb the rest of the problem. Okay, let's balance now. Okay, so if we did a quick inventory, we've got 1C, both sides, 4 waters, 4 hydrogens. Okay, so that's step one. Step two is what is given. Now, this is just like our dimensional analysis we did for unit 1. What's given, what are we trying to calculate? Then there's the setup. So this is exactly the same thing, only it's not a 1-step or 2-step. It's going to be every single time, it's going to be 3 steps. 3 steps or possibly 4. But now if we have 2 givens, that makes it a lot more complicated. But the ones we're doing tonight, we're going to have 3 steps. Okay, so what's given? Right. And it's 15 grams of methane. Okay. What are we trying to calculate? How much water? So we want to end up with water down here. Now, in unit 1, we never had a chemical reaction. So what we're doing is we're just changing the dimensions or the label. We didn't have any chemical reaction going. Tonight, we're going to have a chemical reaction going. That's where the extra step comes in. Okay, so what we're going to start with is a balanced equation, as you remember, is only valid for 2 things. Moles, it's a molar relationship, and molecular, number of molecules. So this says 1 mole of methane will react with 2 moles of water, giving us 1 mole of carbon dioxide and 2 moles of water. 1 molecule, remember, mole comes from the word molecule. 1 molecule of methane combines with 2 molecules of water, giving us 1 molecule, 2 molecules here. Okay, so it's not grams or number of particles. Okay, so if we're starting with grams, what do we have to do? Yeah, we want to convert it to moles, so then we can use the balanced equation to figure out the ratio. Okay, so the molar mass, we need to convert it to moles. And notice we have to we want the grams to cancel, and mole will be on top. Okay, so we need the molar mass for methane. Okay, so carbon is 1201, hydrogen is 101. So that's So that's 16.05 grams per mole. And again, that comes from the periodic table. Now we have moles of methane. We don't want moles of methane. We want moles of, we're trying to calculate, moles of water. That's where the balanced equation comes in. So I'm going to put methane in the bottom so it cancels. Water on top. So now, if we did this calculation, we ended up with moles of water, not grams of water. So now we have to convert the moles of water to grams of water. So we need the molar mass for water. Okay, oxygen is 16, water is 102. Now the ratio of water to methane from the balanced equation is 2 to 1. What's the number in front of the CH4? 1. Okay. So these are the 3 steps. You're going to have a given converted to a mole, step number 1. Step number 2 is the mole ratio from the balanced equation. Then the last step is to take the calculated we want to take the mole to what we're trying to calculate. So we go, in this case, given to mole, mole ratio, mole back to calculated. Every single time. Every single time. Now there may be one other step. If, for example, instead of grams, they wanted kilograms or something like that. But normally there will be 3 grams or 3 steps. Okay. What about sig figs? How many sig figs are in the answer? Three. We have 3 here. We have 4 here. What about in the middle here? Exactly. It's a perfect ratio. So that has infinite sig figs. And then over here on the last part, we have 4 sig figs. So our answer is going to be 3 sig figs like you guys predicted. Good. All right. On your test, if that problem is worth 10 points, the setup is worth 9 points. I've even picked up my calculator. Speaking of, oh no, it's okay. So a review. My calculator gave me 33, 68, 2, 2, blah, blah, blah. So for 3 sig figs, I go to the 4th place. And that's 5 or greater. So that kicks the 6 up to a 7. Okay, so to get the last point, you need to have correct number of sig figs, the correct unit, and obviously the correct number. Now that is a very, very typical stoichiometry problem. Now I've given you, I'm going to say, an S load of practice on these. If you go to files, or if you go to, well, you'll see files. I have like a whole bunch of files there. It'll say let's say gram stoichiometry or something like that. But there are a lot of worksheets there, a lot of practice, and of course the answers. All right, so I'm going to go over a bunch of examples tonight. Now, when we're working with stoichiometry, we need to work, because we're doing dimensional analysis, we have to work with conversion factors. So we're going to be working with 3 conversion factors tonight. And you've already seen them all. That's Avogadro's number, 6.02 times 10 to the 23rd over 1 mole, and its inverse. We also are working with another conversion factor, that's the molar mass. That comes from the periodic table. That's the decimal numbers all added up for the formula, and its inverse. And then we have a new one tonight, is working with gases, which is our next subunit after this. At standard temperature and pressure, all gases will occupy 22.4 liters per 1 mole. And then there's the inverse of that. Okay, so these are the 3 main conversion factors. Now, you need to know these. The one from the periodic table, you don't have to know, because I'm going to give you a periodic table. The other ones, you just have to know. Okay, so are there any questions so far about this process? Okay, so let's do another problem. Now notice, no one's asking me about this double arrow stuff. Can anyone think of an idea why I put 2 arrows up there rather than just the 1 arrow going forward? Yeah, every reaction goes both ways. Now, sometimes it's really lopsided, where it's like 99.9999% one way or the other, but all reactions have 2-way, okay? So I normally put it down here. If you look in your book, you'll see 1 arrow. And then later in your book, they'll start putting in 2. But the reason for 2 is that both reactions happen all the time. Okay, so it's the same chemistry. We're still burning methane, which is the main gas that comes out of your, for gas stoves, they use methane, natural gas. They also odorize it, because methane, you cannot smell methane. So if you have a gas leak, you would not be able to tell if you have a gas leak. So they put an odorizer in there so you smell it. That's the main part of natural gas, is methane. Okay, so let's balance this guy like before. Okay, so all right, 29 grams of carbon dioxide is produced. How much oxygen was consumed? So we have a given. We've already balanced the equation, step number 1. Step number 2 is what's given. Step number 3 is what are we calculating? What are we calculating? Yeah, so we're trying to calculate the oxygen though. The given is the CO2. So we're gonna start with 29. And we're calculating grams of oxygen. All right. Step one is the same. What is step number one? Convert to what? Step one. You need to send me the Gmail so I can send you that paper. I was driving here, I remembered I should have just printed it off. But I forgot. So. All right, so the molar mass for carbon dioxide is we have 1 carbon, 2 oxygen. Carbon is 1201. Oxygen is 16 apiece, so that's 32. Then at 4401. Okay, so that's step one, get to moles. Now there is a theme in this course. If in doubt, convert to moles. If in doubt, convert to moles. Normally moles is like a hub on a wheel. You can, once you're at moles, you can usually go wherever you want. Okay, step number 2 is we want to convert from carbon dioxide over to oxygen. That's where a balanced equation comes in. So the carbon dioxide has to cancel, so that means it's got to be on the bottom. Oxygen's on top. So that's step 2, balanced equation ratio. Step 3 is now we want to take our moles of oxygen to our calculated, which in this case are grams of oxygen. So again, that's the molar mass of oxygen, which is 32. So notice now again, our dimensional analysis, everything cancels except what we're trying to find. We're trying to find grams of oxygen. If everything doesn't cancel, giving you what you're trying to calculate, your setup isn't right. And this works every single time. Okay, and again, that setup right there is worth 90% of the points. And sig fig wise, we're looking at 3 sig figs, 4 sig figs, infinite sig figs, 4 sig figs. Our answer is going to be 3 sig figs. So that's 42.1. Okay. Notice again, 3-step setups, 4 if you count balancing the equation. Okay. Step 1, get whatever you're given to moles. Then empower your balanced equation ratio. Then convert whatever you're trying to calculate from the moles to whatever, whether that's grams, liters of gas. I'm going to do some of these, number of molecules, whatever. Okay, so I want you guys to try one of these on your own. Okay. Try this guy on your own. Because it's liters of gas. Remember, what was one of our conversion factors? It was 22.4 liters per mole for all gases. Now, whenever I say how much, that usually means grams.
But I'm guessing it means that in this case, or does it mean liters in this case?
It means grams. So we're starting with liters, ending up with grams. Remember, the first step is always the same. Convert that to liters using the 22.4. Yeah. Step one, no matter what I said. Okay, balance the equation first. Does anyone want a mechanical pencil? It's a 0.5. It was left here. I hate 0.5, it breaks all the time. Huh? Oh, Ricky. How many liters are in a mole for gases? Go back to the 3 conversion factors I gave you.
Yeah, what do you find was the conversion factor?
I might just take a photo of that, honestly.
Oh, yeah, that's a good idea.
Because I'm not gonna be able to write it down tonight before we have to move back to the problem.
Jerry, write down the problem.
Yeah, but
Oh, yeah. All you need. I hope my new gadget works. Yeah. So everyone can hear me clearly now as I'm walking around. Huh? Gases are always at STP, standard temperature and pressure, at 22.4 liters in 1 mole.
so that's what we need for this one. Okay.
Doesn't matter if it's oxygen, nitrogen, helium. If it's a gas, it's 22.4. Now we're going to change that when we get out of non-standard temperature and pressure. But for right now, it'll always be STP. And liters is capital L, not small l. I found out what I'm teaching in the fall.
And we're translating it.
Hmm?
And we're translating it to grams.
Teaching another one of these in the fall, double section of it.
That interview to be full time.
That'll all change then. The interview was hard.
Oh, you already had it.
It was yesterday.
Oh, I just feel like it went. You said it hard, but
Everything went well except for one question. The guy was acting like a student was having all these horrendous problems. And then the way the student set it up was, I wouldn't do it like that at all. It was really complicated. I like real clear.
Yeah.
And, but because we were on Zoom, he was sharing his desktop, so I couldn't write on it. So I was trying to explain it, and it just, that's the only thing that
Yeah, that would make it much more difficult.
yeah, I
If you
almost,
were able to share yours, you'd probably be able to explain that.
well, I had to present a lesson. So I had my little Zoom tablet, you know, and everything I shared with everyone. But I don't know if Zoom, you can do a mutual sharing or not.
Depends, I guess.
I mean, I've never had this situation. It'd be nice though, having a remote deal with students where they could actually run on my deal. That'd be kind of cool.
That'd be good.
But-
One day, I think it was like you have to share the document with them or something.
Yeah. There's a way if they're logged into Zoom and they are running OneNote, that's one way to do it. But it's not through sharing though. It's through OneNote. The share is through OneNote. But he wasn't using OneNote. I mean, it was I was a limited amount of time too, and I kept trying to work around it, and I
So they just act like they're a student and then once they're a teacher.
Yeah.
do they actually ask the other questions.
they had a whole bunch of other questions too. And those are real standing. What would you do? You know, blah blah blah. You know, what if you had a disadvantaged student, or if you had a skirmish in class? What would you do? I've never had that in my class. Never. And I've taught community college for over 15 years. Never. I taught high school.
That's another thing.
Different story. And they're mostly between two girls. So
Really, I thought it would have been a bunch of boys.
no, the whole drama thing. Doesn't matter if you're teaching honors chemistry, advanced placement chemistry, drama comes to class. Here, you're having drama, you just don't go to class.
Let's be honest, I mean, in college, everyone's just like trying to get their degree.
Yeah, I know. I did. Yeah.
So, because there's two oxygens
Mhm.
or two O2s, it would be set up like this.
Yeah, but you gotta have the two there because there's two over here.
Yeah, but then how?
And
does
this
that
is
still
this
cancel
just
out?
this just
Okay, so that cancels that.
yeah, but the two's still there though,
Okay.
because this ratio has to be maintained. And your setup is fine. That's how to do it. So you listen. She arrives. Hmm?
Just 30 minutes late. Are we using grams or liters?
It's gonna be when they say how much, it's grams. Otherwise, I would have. Did you convert it to liters?
No, I was just, she
We
made a good,
we were kind of stuck on if we had to add in a second conversion at the very end, to convert it, right? Like,
It's always three. Always three. The last one is going from moles to grams or liters or
yeah, so we did the liter
initially the moles and then,
yeah,
liters.
exactly like that.
okay,
Yeah.
perfect.
Wait. Did you get this right? I finished the late class.
You did. And this is infinite figs, right?
No, it's three.
Is it 3?
Yeah.
I just figured
This is infinite
Oh,
because this
this
is
is-
perfect. You know,
this one's not the,
No.
okay.
that's definitely three.
I forgot to put the 2 by the oxygen.
Okay.
Okay. Oh, okay, that was the only thing I did. Wait, so how do you, never mind.
Is that one node?
Yeah.
I was gonna say, it looks just like one node.
It's just on a Microsoft Surface tablet.
Did you get,
When I was in Tacoma, I set up my advanced class. So they had to actually have a class, we had a class set of OneNote. And so as I was doing that,
Mhm.
it would be updating your tablet.
Oh, that would be awesome.
And then you could change, you could write on yours and it would update that one.
Oh, like a live doc.
Isn't that cool?
That is, yeah.
It was a pain to set up though.
Oh,
I only did it
sure.
with my smaller classes. When I
for
had
sure.
a double section of 50 students, that was,
Because we do the same thing in our like our staff meetings, but it's with like Google Docs, and so people can live edit into the Google Doc as it's opened and
yeah, the concept is the same.
yeah. 8.38, yeah. Sorry.
Yes, you guys, I think are catching on. Okay, 3 steps. First step is liters to moles, using 22.4 liters per mole. Yep. Middle step is a ratio from the balanced equation. Last step is converting to grams. And the answer is 8, is it 8.39 or 8.39? Okay. 3.8. Okay. All right. So let's do another one here. Okay. 5 grams of water is made. How many liters of oxygen were consumed at STP? Now, a couple of things. As soon as I say liters, what conversion factor are you going to be using? Yes, you're going to be using the 22.4 liters. Now, in unit 5, we're going to be talking about liters, liquid liters. So we have gaseous liters, liquid liters, and they're totally different. They're just liters. That's the only part that's common between them. So the 22.4 has to be referred to with a gas. Okay. So the answer to the last one was 3.8 grams. Shouldn't it have been 3 sig figs? .38. Oh, 38. Okay. What did I have? Did I write down 38? Oh, I did. We'll forget that. Okay, so what's given in this problem? Exactly, grams of water, 5.00, okay? And we're calculating liters. So we're going from grams to moles, mole ratio from the balanced equation, and then moles to liters. Notice it's always 3 steps. Always 3. I need to burn that into your mind. It's always 3 steps. Yeah.
So because of the conversion factor for the second step where it's like the element or like the
Coefficient ratio from the balanced equation. Yeah.
since they're both 2 in this case, does that mean they just cancel out?
Yes, it's still going to be there though.
Okay.
And yes, they cancel out
But
because it's a fraction.
I could just like draw a line through the middle of that and just be like,
Or just ignore it,
Nice.
one of the 2. Yeah, exactly. Yeah, it's a fraction. So 2 over 2 is the same as, 1. In fact, there's a deal in math. It's called the, I used to major in math too. Okay, but it's called the unison theorem or something like that, where everything equal over equal is always equal to 1. And then 1 times anything is itself. And it's kind of a mathy thing. How'd you get 34?
Because it's H2O.
H2O is 18.02.
Oh, I must have done 2 oxygens instead of 2 hydrogens.
Oh, yeah, that makes sense. Now, on the test, had you done that, this problem's worth 10 points. You wouldn't have missed 10 points. I would have seen your error. I would have dinged you there.
Yeah.
I would have dinged you for your answer. So you would have got 8 because your setup is good.
Mm.
That's called partial credit. Just making sense? Yeah, the 20, well, we just talked about it tonight, so. Now it's imperative you understand this process tonight, because my video on the next step, I'm going to give you a little bird's eye view of what to do with it, but it's crucial you understand this simple problem. Easy for me to say simple, huh? You know, I put a grid down to keep my line straight. I think there's a problem here.
I mean, I'm pretty sure there's like a tool that you can use to make lines.
Yeah, there is. Under shapes.
I'm definitely not gonna be able to see him.
I always do this.
I mean,
This is because I always look up in life, being positive.
you might be able to find a way to like insert a chart or something that you could just basically use as that. And
I'll make a custom shape.
yeah, basically a custom shape that has like the lines in between.
Yeah, that's a good idea.
Like it would have like a box.
Exactly.
Just the lines in it.
But it's always the same number. So a custom shape for doing stoichiometry would be perfect
Exactly.
because it's the same thing every time.
Yeah.
And see, that's the thing I'm stressing tonight is everything is the same every time. Every time. And I gave you on those practice sheets I gave you, when you look at the answers, you just look down and they're all the same. So you're just figuring out what's given, what are you trying to calculate, balance the equation. Next. Like you can get 90% without even picking up your calculator. Because you get 9 out of 90% on credit for the setup. So it's
I'm just doing some.
I know.
doing stuff to keep myself just thinking.
Okay, well, this is the setup here. Cancer is going to have 3 sig figs. I'm going to do one more tonight. And I'm going to give you a harbinger of what that video I'm going to do for you looks like. Now, a couple things about this. Notice I have 2 over 2 and everyone's going to go, oh, that's the same as 1. Do we have to put both 2's down? Yes. for the setup, you need to have the 2 and the 2. However, when you're doing your calculation, because 2 over 2 is equal to 1, you can ignore the 2's. But as far as the setup goes, make sure you have the 2 over 2 down.
So the molar mass for gases is the same for 1 mole?
Every gas, regardless,
Okay,
we're talking about uranium hexafluoride gas, which is super heavy. It's a gas though. It's only 2.4 liters at standard temperature and pressure versus helium, which is super, super light. They're both 22.4. So all the gases, no exceptions. Now and that's the ideal gas. There's non-ideal gases, which you get into in Chem 1B. And what changes that, there's some other colligative factors and and stuff. But basically, at standard temperature and pressure, 22.4. That was a good question. All right, we're going to do one more, and then I'm going to show you why it's important to understand this simplified version. Okay. See you guys handle this one. 23.7 liters of methane are burned. How many molecules of oxygen gas were consumed? So the first thing we're going to do was, what's the first step? Balance. Perfect. What's the next step?
What's given?
Given. What's given?
Liters of methane.
Yeah, 23 liters of methane. What are we trying to calculate?
Molecules.
Molecules, number of molecules. Now we're going to use Avogadro's number. So let me do this one with you because it's okay. So step one is to convert the liters of gas to moles. Next step, we're going to, from the balanced equation, talk about CH4 in the bottom, so it cancels. And we're trying to calculate oxygen gas on top. Well, we want to go to number of molecules. That's Avogadro's number. So that's the setup. Your answer is going to be 3 sig figs. So this step here gets us from moles of oxygen to number of molecules of oxygen.
You said like the little, the calculators, how you just put like 6 by 223.
Yeah, so you go 6, is it double E though?
Yeah, the E.
Yeah, exactly. What that does is that glues the 10 to the 23 to the 602.
Okay.
Instead of
You don't
using
have to put
parentheses.
10 or anything.
Exactly, none of that. You know, but times 10 and 2 parentheses. All that's done in one keystroke.
So molar masses don't count as conversion factors, so you have to count. the
Because we're not in
different
grams.
figures.
Molar masses were with grams in it. We're starting with liters. That's why you have to use this one. Nice calculator. Just kind of have at home.
This one's like a backup in case it runs out of battery.
Mine lasts a long time. though.
Or in math classes or in some classes, you're not allowed to use this, so I have this too.
I know. Have you ever put anything, stored anything in memory on this? It's such a pain to do, and it's cryptic and everything, but yeah, a lot of professors won't allow it. And with me, I just say, clear it, and you can use it.
But it's like calculus, this makes it so much easier. It does everything for you.
Yeah, including matrix. I use class, there's an extra credit chemical balancing equation under files. And if you choose to do that, it's not simple. That's why I'm giving you extra credit. And turn it in with your tests, test 4.
How many extra credit points this week?
Probably count as a 10-point question, something like that.
Oh, and do we have a wet lab this Thursday?
Yes, wet lab is on stoichiometry this week.
Which line number is that?
No, it's just,
So you've done 11. Yeah. Pretty sure we've done 11.
it's probably 12. I don't know. Just look for stoichiometry. If you look on the schedule, it'll say what lab. I don't remember what it was. Yeah, so it was a mistake. Most people take about 90 minutes to do it, to balance it. 32 seconds. And that's how long it takes to set up the matrix. And you use something called reverse row echelon format, and it goes boom. It's really cool. All right. Everyone get the same answer I got? Yes, you did. Good. I was checking to see if you got. Okay, I think you guys are really getting this. Okay. Okay. So, what do you guys think? Do you want me to do the second part of this lecture tonight, or would you rather me put it in a video? It's called limited reactants, limiting reactants. And then I'm going to give you 2 givens, which really complicates things. Now, if you're struggling with this concept tonight, this will just make it really confusing. Okay. So actually, a lot of you are really doing well on this. You're just whipping it right out. So what would you guys like to do? Want to do the video, or want me to do it here? Huh?
Been a long day. I
Okay, I tell you what, I'm going to show you really quickly what's going on. Then I'm going to do a long, extensive video, okay? All right. And I'm going to